I'm Stefano Dettori. I'm a assistant professor at the Scuola Superiore Sant'Anna. Basically, I introduce very briefly my research group that is called the City COISP, and basically we are a multidisciplinary team, a set of engineers, information scientists, and mechanical engineers, and so on. Devoted basically to industrial research. And our main focus is basically the metallurgical sector, and where we deployed and developed several machine learning, artificial intelligence techniques, but also several other activities. As Scuola Superiore Sant'Anna, in particular the City COISP, we are very involved in the research, obviously, as an academia sector. And in particular, we worked on 84 European funded projects, and currently there are 17 ongoing European projects. And also we collaborated a lot with private companies with the idea of, let's say, transferring the knowledge, and also create some prototypes that can be useful for the industry, in particular the metallurgical sector. We hold 24 years of experience in terms of research, but also research activity on commission, and also very important the training courses, training session for industrial partners. I'm going to introduce let's say the main results related to the case study related to the foundries in the ALCHIMIA project, where in particular we developed a monitoring and prediction tool that allows the users to identify the defects in the production in foundries, with a particular focus on brake discs. What we solve with our system, with our software? Well, basically, there are two main difficulties. The first one is the fact that in general, in the foundries, it's possible to identify defects only after the casting, and in particular after the cooling of the products. So the operators check the product, or at least some sample of the batches of the product, to identify the defects doing some specific analysis. Well, through this software, we can identify defects 2 to 3 hours before the final, let's say, product. And this can, let's say, save us several costs and several reworks on the production. The second point is the fact that, in general, since we are dealing with, let's say, rail events, because we would like to produce, let's say, in principle, zero defective products, but, phenomenon and manufacturing defects happens. And so we would like to recognize rare events, let's say, among, let's say, an important amount of nominal condition, obviously, that are the majority. And so it's difficult to create process models that forecast rare events, in particular through data, exploiting the data, basically, the data of the plant. Well, in our system, we integrated several artificial intelligence-based models to analyze real-time process data that we receive from the ETL, in this case, that in this ALCHIMIA project, the ex-colleagues developed, in order to provide an immediate estimate of the risk of the defects on the production. So, exploiting the plant data, consume this data in AI models to have some outputs in terms of classification of defects, or let's say forecasting of specific phenomena. Real-time prediction, because the AI models continuously analyze the plant data and provide operator with an immediate indication of the risk. And this allows us to also to have a possibility to understand how to intervene in the process in terms of controlling some parameters, for example, the temperature of the casting or the inoculants, or how to change maybe the chemical composition of the cast iron and so on, in order at the end to reduce the waste of the production. The other two important points are obviously a graphical user interface that is interactive with the users, that give us, let's say, a dashboard that displays the process data, prediction, info, and several information that can be accessible also to non-user expert. The system is scalable, integrable in terms of architecture in order to be easily connected to the existing supervision and control system. And these two features allows us to improve the operator's awareness and facilitating the quality control. And also it's a good base for, let's say, help the transition to the digital factory. The target audience of our system, well, basically the tool is designed for foundries, but in general it's applicable for manufacturing companies that has data to for let's say design artificial intelligence based model, and with the idea to focus on quality control. Target user, well, production team, innovation team, in particular engineers and process technicians that works in the production, and the innovation teams in terms of data analysts and digital innovators. The use case for which we developed the system is Fonderia di Torbole, that is a foundry that mainly is located in the northern part of the Italy, that mainly produce the brake discs, Fonderia di Torbole, and for which we developed a set of tools, a graphical user interface for forecasting some specific characteristics of the production. For example, mechanical resistance through the prediction of the natural frequency of the brake discs, but also specific production defects that happens in particular products, for example, cementite and micro shrings. We developed a set of models for types of products, let's say the main products that where defects occurs, let's say more or less frequently, more frequent than the others, and two types of cast iron qualities. And we validated the results, demonstrating the fact that these models can have an high accuracy even dealing with unbalanced data sets. So this means data sets that have a lot of nominal condition, thousands and thousands of nominal production, and also few defects. For example, we deal with some products defects data sets, in the order where the defects are in the order of 50 more or less. So very few samples. And but the models in the validation phase and also in the test phase are revealing the fact that can allow the operator to identify the defects with quite good accuracy. For example, for microshrink, more or less 88%, for cementite defects 71%, and in the case of frequency, that is a forecasting of the frequency, natural frequency of the brake disc, that is really correlated with the mechanical resistance of the brake disc. Well, in this case, the accuracy of the model, regression model, is quite high. That allows us to identify if the natural frequency of the model of the brake disc is below a certain threshold or above a certain threshold. So identify if there is other effects in terms of mechanical resistance. These tools are available, let's say, are behind a graphical user interface that provide to the operators let's say, an insight on, in this case, the two production lines, where the operators can see the main data of the product, so the reference code, the description of the products that is produced, the type of cast iron that is worked in the specific production line, the last chemical analysis and thermal analysis. And finally, we also have some graphical the pics of the situation, let's say, and provide also the possibility to exploit the inference of the model, so therefore the possibility of forecasting the defects by starting the models and applying some parameters related to the heat, for example, the temperature of the heat, the rate of the inoculant, and so on. And to have at the end a prediction of the quality. In this case, we see, for example, an example where the frequency is within the boundaries, the nominal boundaries, and we see that there are no microshrinks. And for the cementite, we see that is not evaluable because for this specific product, we don't have in general, the defects, and so we didn't have the needs to develop a specific model. To know more, well, you can see the results in the ALCHIMIA project website for sure. And we also published a set of papers. This is an example. And obviously, if you are interested on the product, we can also arrange a dedicated session to test the system with your own specific data. And you can contact us at these emails. In summary, well, we know it's the period of the artificial intelligence, because we are seeing that as a tool is quite effective in specific tasks, obviously, and because they allows us to extract more information from plant data. And our products, our prototype show how this artificial intelligence methodology can become a concrete ally, in this case for foundries, in particular for checking the quality of anticipating the quality of, let's say, the check of the quality of the products. And this allows to reduce the cost and accelerating the digital transformation. For questions, you can take the photo of the QR code and send us some questions if you are interested.